introduce Ms. Jitasmita Banerjee. Actually, she is currently working as an associate data engineer in big data at Celebal Technologies Private Limited. She has completed her Bachelor of Technology in Computer Science and Engineering from Coachbihar Government Engineering College. During her college years, she has worked in the field of Internet of Things and the machine learning. She has acquired a copyright from the Government of India on the Python code created implementing the machine learning regressions model for her projects on a smart plant growth analyzer using sensors and the regeneration analysis. On the professional front, she is a Databricks certified a professional data engineer, certified Azure data engineer and the Microsoft Technology Associate in the security fundamentals. She proficiented in data warehouse, ETL processes, data AI and governance, building pipelines and the dashboards. Currently, she is working as a data engineer in the project of Reputi BFSI client based in Hong Kong. So I'm requesting Ms. Jitasmita Banerjee to deliver her lecture and in the domain of industry section. Thank you, ma'am. Please share your slides.
Hello. Thank you, Arnob sir. And I would be sharing my screen. Please let me know once it's visible.
Yes, it is visible. Please
Okay,
make it full screen.
yes, sir, sure. Yes, so thank you, Arnob sir and Prashanjit Dey sir, for the confirmation. So, hello everyone, good evening. And as Sir has already mentioned in my introduction, I'm Jitasmita Banerjee and I'm currently working in Celebal Technologies as an associate data engineer. So, this is a project which I had done in my final year of my BTech under the guidance of some of my professors of my college. And we have also attained the copyright from the government of India on the Python code that in which we had implemented the machine learning models. So the project is titled as a smart plant growth analyzer using sensors and regression analysis. Okay. So this project is basically an amalgamation of two technologies. We can say two cutting edge technologies. One is Internet of Things and the next one is machine learning. And in machine learning specifically, we are talking about regression algorithms. Now, since these sessions are based on the application of machine learning on sustainable technologies, then what better than the application of machine learning in the field of agriculture? So, and why IoT and machine learning together? So, there are numerous publications. One I have cited here as an example, which is IoT Transforming the Future of Agriculture, May 21st to 23, 2024. So it actually cites how IoT solutions are more focused on helping the farmers to close the gap which is there, which is existing in supply and demand by ensuring high yields, profitability, and protection of the environment. So why we are using IoT is basically what happens often we face losses in the agricultural sector, which can be due to numerous reasons. And some of that may be due to inadequate nutrition that the plants are getting, or maybe we are using some backdated technologies in the farming or the agriculture process that is not making this agriculture very efficient. And because of that, if we are trying to incorporate the cutting edge technology, which is Internet of Things, with that we can actually help the farmers to close the demand and supply gap that is prevalent. And with that, we can ensure high yields, profitability, and protection of the environment. Okay, so the approach of using IoT technology to ensure optimum application of resources to achieve the high crop yields and reduce operational costs is called precision agriculture. And IoT in agriculture technologies comprises of some specialized equipments, wireless connectivity, software, and IT services. So all in all, it's actually going to modernize the prevalent practices which have been going on for numerous decades in the agriculture sector. So we are moving now towards something called as precision agriculture, which is going to promise us that we will be now getting higher yields, better profitability with better good quality of crops. So this project, as I've already said, is the amalgamation of the data that I have collected over a period of a month, which is 30 days. So I will be taking you over to the data set as well. So the data that was collected using the IoT sensors, then we have done some processing. We have first stored that data in the cloud. We have transformed that data. We have done some processing. We have shared the data over the internet, and then the analysis and the prediction for that data was done using the machine learning regression algorithms. And thus it is creating a compact model that is able to monitor, predict and estimate and reason the plant growth by monitoring the three essential factors which are required for the growth of plants. So in this project, I have mainly tried to focus on three factors on which the plant growth depends, which is the sunlight, the soil moisture, and the soil temperature. Now, obviously, the growth of the plant is not focused on these three factors only, but we will be discussing about these three factors, how we can predict the dependence of these three factors on the growth of plant. And then I will also take you to the future scope where we can discuss how this project can be further expanded. Okay, so the main three factors are sunlight, soil moisture, which is the water content of the soil, and also the soil temperature. Okay, so firstly, before going to the project, let's have a brief walkthrough on what is Internet of Things. So Internet of Things is described as when physical objects, they are connected over the internet with the help of sensors and some cloud. Okay, so with that, we can actually exchange the data between various devices. So most common examples of Internet of Things today we can say are smart homes. So now I don't even have to get down and take the remote and then increase or decrease the temperature of an AC. I can do that with the help of Internet of Things. I don't need to go and switch on the light or switch on the fan through the switchboard. I can just do with the help of Internet of Things. All of this is coming under smart homes. And this is a very simple example of Internet of Things. And today, Internet of Things finds its application in all and numerous fields of our day-to-day lives, starting from smart cars to smart watches to smart homes to its application in some other fields like I'm talking about agriculture, we can say healthcare, so on and so forth. There are numerous and myriad of applications of Internet of Things in today's world. Now, why is it so important? IoT has become one of the most important technologies of the 21st century. We can nowadays connect everyday objects starting from kitchen appliances, cars, thermostats, baby monitors to the internet via the embedded devices, and seamless communication is now possible with the help of IoT between peoples, processes and things. And by means of low cost computing, the cloud, big data, analytics, and also mobile technologies, physical things can now share and collect data with minimal human intervention. In this hyper-connected world, digital systems can now record the data, monitor the data, adjust the data, each interaction between the connected things. And now the physical world has definitely met the digital world, and now they are cooperating with the help of this IoT technology. So in this graphic, we can see that how IoT is now deeply embedded in each and every sphere of our day-to-day life. Okay, now let's talk about IoT in agriculture. So every year, a major portion of the agricultural sector faces some serious losses due to the various due to the lack of facilities that are present to monitor the plant growth. So as we all know that India is an agro-based economy, which means that a majority of the economy is dependent on the farmers and it is dependent on the agricultural sector. Saying so, if the agricultural sector is facing losses, it means that the entire GDP of our country is going to go down. So it's high time that we put proper focus into the agricultural sector and we utilize the IoT and cutting edge technologies like machine learning so that we can make this process more efficient. Because because the existing agricultural technologies are all outdated and they are no longer serving the purpose. So we need IoT intervention in the field of agriculture. Also, due to the lack of proper understanding, education, and availability of the new generation facilities encompassing the agricultural domain, adequate measures cannot be undertaken that can enable the researchers to decipher the underlying causes of agricultural losses. So often what happens, the existing processes of agriculture are so outdated that the researchers are also not able to understand why we are incurring those losses in the agricultural sector. So this demands that we use Internet of Things in the agricultural sector so that we can make this process more efficient and we can also provide a solution that why the losses are being faced in this domain. So let's come, we can see that how Internet of Things is transforming the agricultural sector. So it helps with the crop yield analysis. So we can analyze how the crop yield is going to be with the IoT technology, auto spreading, diagnosis of various diseases, then variable rate of fertility, water stress, field monitoring, soil erosion, smart data. So all of these are the various facets of how IoT is going to transform, or it is actually transforming the agriculture sector. So now we have gotten an introduction that why we are using Internet of Things for transforming the agricultural sector. Now let's understand what was the background of the project. So as I've already said that we will be discussing about three major factors, which is the sunlight, the temperature or warmth of the soil, and soil moisture. Because these three have a common and a major contributing effect to almost each and every common plant. Now, talking about the effects of soil temperature, it affects the metabolic activities of the plant as well as the nutrient uptake from the root. Sunlight, on the other hand, provides the energy the plant requires to convert the carbon dioxide that is present in the air and water into carbohydrates and oxygen. And the light intensity influences the manufacture of the plant food, stem length, leaf color, as well as flowering. And lastly, the soil moisture also affects the plant root water absorption and leaf transpiration, which further affects the dry matter accumulation and ultimately affects the crop yield. So all in all, we can see how these three factors are very important to determine to determine the optimum plant growth. Okay. So this is, we can say, the basic outline of the project. So what we are doing is we have taken a plant, and I will also tell that why I have taken a particular plant. So let me tell you, the project was conducted using a marigold plant. Okay. Now you might ask me that why I've chosen a marigold plant. Now there are certain reasons behind choosing the marigold plant as the sample for this project. Firstly, it's a very easily available plant. And also the life cycle of this plant is quite short, and therefore we can actually get better results in a shorter period of time. Also, marigold has actually medicinal benefits. It is used in numerous occasions. It has a huge medicinal value as well as economical value, because in India we use the marigold flower, we use the leaves for various purposes. So obviously if we can identify the problem in such a plant which is very important and which is very commonly used in the Indian economy, it is going to be beneficial. And then we will be actually implanting certain sensors, namely three sensors, one for sensing the sunlight, for the soil temperature, and then for the soil moisture. Now the data that we are going to get on a daily basis from these sensors, we are going to send that to the cloud, and there we will be doing There we will be doing some transformations on that data. We will be implementing our machine learning regression models, and then we are going to get the necessary output. Okay. So now let's go to some statistics that mention the importance of agriculture from the India's perspective. So it's going to give us a better perspective that why it is so important to actually, make certain changes in the agricultural sector from the India's point of view. So India is the second largest producer of wheat and rice, which are the world's major food staples. India is currently the world's second largest producer of several dry fruits, agricultural based, textile, raw materials, roots and tuber crops, pulses, farm fish, eggs, coconut, sugarcane, and numerous vegetables. In terms of employment, the agricultural sector provides livelihood to about 151 million people, and approximately 60% of the Indian population works in the agricultural sector, contributing to about 18% to the India's GDP. So it's high time that we pay focus to the agricultural sector of India. Now let's come to the IoT components that we have used for this project. So the main brain of this entire hardware that I have designed is basically this Bolt Wi-Fi module. It's going to provide us the internet connectivity to our hardware, and also all our sensors are going to be attached to the Bolt Wi-Fi module. So we can say that this is the heart and soul of our hardware. Then we can see we have the light dependent resistor, and this is going to help us capture the sunlight intensity that is falling on our plant. Then we have a 330 ohm resistor that is used along with our LDR, or the light dependent resistor. We have our LM35, which is a temperature sensor, and it is going to give us the value of the soil temperature in Celsius. And we have a soil hygrometer that is going to give us the soil moisture content. So these were the IoT components that I've used in the hardware. Now let's come to the Bolt Wi-Fi module. As you can see, this is how the module looks like. And we have certain pins in which we will be making the connections. So let's come to the important pins. We have an A0 pin, which is the analog input pin. Okay, and this pin is basically inbuilt with an ADC, which is an analog to digital converter. And this is the only analog pin which is present in the Bolt Wi-Fi module, to which we can connect our sensor. Okay, and this is the only input pin. So this only collects the input. It is not going to give any output. Then we have certain pins which are numbered as 0, 1, 2, 3, and 4, and these are the digital input output pins. We can connect this to we can connect a digital sensor to this pin. Then we have certain other pins, TX, RX, and these are some universal asynchronous receiver transmitter and universal asynchronous receiver transmitter pins, which are used to receive and transmit the data. And then we have a 3.3 volt pin, which is going to provide the power supply to our hardware of 3.3 volts. We have the 5 volt pin as well, in case we need to provide a 5 volt supply. And we have a ground pin that is used to ground and complete the circuit connection. Okay. And then talking about the software that I've used is basically the Bolt Cloud platform. And here what we can do is we can actually, once we have successfully installed the hardware, we can set up the hardware. And once we have made the necessary connections to our Bolt Wi-Fi module, we can set up the hardware, we can link our product, and then we can actually write the code. Like what I need to do is I needed to graphically plot the sunlight intensity, the temperature, and the soil moisture over the sample data collection period. Okay, so for that I wanted to import certain Google library charts so that I can plot the data. And here you can see that we have imported the Google Charts library, and we have just written very simple JavaScript code, and this simple few lines of code is actually going to help us visualize the data that is collected by the sensor. So all of this was done on the Bolt Cloud platform. And in case you need to visit it, you have the URL right here, which is boltiot.com. On this platform, you can actually create and set up all your IoT products. You can set up the hardware, and then you can link the Bolt Cloud from this portal itself. And then you can visualize the data that is being collected by the sensor over the time period. And we can actually also connect our hardware to our mobile using the Bolt mobile application. You can set up the internet connectivity, you can set up the hardware and check whether your hardware is properly functional or not, all using this mobile app. Now let's have a brief discussion over the three sensors that I've used for this project. So as I've already told that we will be discussing about the three main factors, let's come to the first factor, which is the sunlight intensity. We all know that sunlight is very essential for optimum plant growth. And for measuring that whether optimum sunlight is falling on the leaves or not, we have used the LDR, or the light dependent resistor. So let's discuss how it works. So light dependent resistor, which is also known as the photoresistor or the photo cell, it is actually a resistor whose resistance varies depending upon the amount of light that is falling on the surface of the resistor. So you can see in this diagram that when no light is falling, there is no output voltage. But when certain amount of light is falling, we are actually getting some output voltage. So when the light is falling on the resistor, the resistance is actually going to change. Okay. So here in this graph, you can actually visualize how the resistance varies with respect to the light intensity. So this sensor was used to detect the amount of sunlight that is falling on the sample, which is my marigold plant. Next, we have our second factor which affects the plant growth, which is the soil temperature. And for measuring the soil temperature, I have used the LM35 temperature sensor. So it's basically a temperature measuring device, and it has an analog output voltage which is proportional to the temperature. So based on the voltage, we can get an idea of the soil temperature. And it provides that reading in Celsius or centigrade. It does not require any external calibration circuitry, and it is also more precise than the thermistor. And that's why we have used the LM35 sensor for measuring the soil temperature. So here are certain specifications which tells us what is the operating voltage, output voltage, sensitivity, so on and so forth. Let's come to the third sensor, which is the hygrometer or the soil moisture sensor. And it is used to measure the dielectric permittivity of the surrounding medium. And it is basically, it gives us an idea of the water content of the soil. It creates an output voltage that is basically proportional to the dielectric permittivity or the water content of the soil. And thus we can get an idea of amount of water that is retained in the soil. And we have also used a resistor, which is a 330 ohm resistor with a tolerance of plus minus 5. The color coding is done with the four bands, which is orange, orange, brown, and gold. And it is actually used along with the LDR or the light dependent resistor. And this is the circuit diagram. So in this way, we had actually made the circuit connections. You can see that we have connected the 330 ohm resistor along with the LDR. So this is one connection for the LDR. Then for the LM35 sensor, this was the connection. And then for the hygrometer, this was the connection. You can actually see that all the connections were made like here we have connected one end of the LDR to the ground to the 5-volt pin, which is going to provide the power, and one end to the A0, which is our analog input pin. Okay, and we have also connected the 330 ohm resistor, one end to the ground and one end to the A0, and so on and so forth. We have done all the connections for the three sensors, and this actually completed the hardware setup for my project. Okay. Now let's come to the data set. I will also show you the data set. So what I had actually done is that I had taken the data of these three sensors at thrice. Every day I had taken the data, collected the data 3 times per day. One in the morning, one in the afternoon, and one at night. And why so? Because like if I just try to predict the change in the change in the height of the plant or the growth of the plant on the basis of the sunlight intensity, temperature and moisture just at one particular instance of the entire day, it's not going to be that precise or accurate. Why so? Because the temperature, the sunlight intensity, the moisture content of the soil varies throughout the day. Like during daytime, the sunlight intensity is definitely going to be much higher as compared to the evening or at night when it's going to be the minimum. So just for that, just to increase the accuracy and precision, what I had done is I had collected the data at three times each day for a period of 30 days. So this is basically a screenshot of my data set, and I'm actually going to show you the data set as well. But before that, this was basically the sample or my marigold plant on which I had conducted the experiment. And before we come to the machine learning part of the project, I will actually show you the data set. Uh, so I hope my screen is visible. This is basically the data set. So you can see that I have collected the data over a period of 30 days. And the first column is basically the day number, which gives me that which day is it. Then we have the date of the data collection. And then we have three columns, which is sunlight average, temperature average, and moisture average. Now, why average? As I just mentioned that I had collected the data at three particular intervals, one in morning, one in the afternoon, and one at night. Then we had actually taken the mean or the average of the three values. And then we have recorded those values in these three columns. Okay. And then we have our plant height. So initially the height of the plant was this, which is 13.3 centimeters. And then with every passing day, I have, measured and noted the height of the plant. But just let me tell you this, that the height of the plant could not be an essential or a very effective measure to understand or predict the growth of the plant, right? So just for that case, we have taken height difference as the output factor or the output parameter that is based on these three input factors or input parameters, which is namely sunlight, temperature, and moisture. So our output variable is basically the height difference. So we have taken the initial height of the plant, height difference, as 0. And starting from that, we have calculated the height difference of that current day with respect to the previous day. So this is my data set that we have gathered. Okay. Now let me take you to the machine learning part of the project. Okay, so the methodology, as I've already mentioned, that the readings of the sensors were taken with the hardware being installed on the plant, and the readings were taken three times a day, one in the morning, one in the afternoon, and lastly at night. Okay, and I had measured the plant height using a centimeter scale, and okay, so the soil moisture was maintained according to the needs of the plant. Periodic watering was also done to the plant, and based on that, we have seen the variation in the value of the soil moisture sensor. So we will come to the machine learning aspect, but what I want is I actually want you to take to the code so that you can have a better understanding of what was actually done. Okay, so this is the code that we had prepared in Python, and we had implemented our machine learning models, and we have done our prediction. An entire project has been implemented in Python. Now, why Python? Python has certain inbuilt libraries or packages that helps in machine learning, that helps us to implement certain machine learning models very easily. So this is the code. Let me take you through the code. Okay, so what we are basically doing is, first we need to import the data set which I just showed you. So for that, first we will be importing some very basic libraries like the pandas, numpy, csv, scikit-learn. Okay, and we need to import the train test split. So what we are actually doing is we want to predict the growth of the plant on the basis of the three input factors, namely sunlight intensity, the temperature of the soil, and the soil moisture. So these three are the input factors, and these actually affect our output, which is the height difference, which is going to give us a measure of the growth of the plant. And for that, we have imported the train test split. split. And then these we have imported SVR, which is support vector regressor model. So these are all the models that we will be implementing. And every analysis becomes better when we can visualize the data. And for that, we have imported the matplotlib, which is going to simply help us to plot the data so that we can understand which model is working more efficiently on our data set. And obviously we need to calculate the accuracy or the precision of the model, and for that we will be using certain metrics like mean absolute percentage error, mean squared error, mean absolute error, and the R2 score. So for that we have imported those as well, and we have also imported the Pearson correlation. So, and this is my data set. So the first command is a very simple command where we are actually reading the Excel data set. So you can see this is my data set that has been imported, and we have 30 days of data. Okay. So then we will be doing our train test split. But before that, I just want you to take you over the machine learning part of the project. So let me just present. Okay. So machine learning, it is basically a growing technology which enables the computers to learn automatically from the past data. We all know what is machine learning. So the system is going to learn from the historical data. It builds the prediction models. And whenever it's going to receive the new data, it's going to predict what is going to be the output for that data. Okay. And that is what we are trying to do in this particular project as well. We are trying to build a prediction model. Now, talking at the high level, broadly, we can classify machine learning into three types: supervised, unsupervised, and reinforcement learning. And we are mainly focused on supervised learning, where it is a type of machine learning in which we can provide sample label data to the machine learning model in order to train our model. And on that basis, it is going to predict the output on the test data set. Okay. And in supervised learning also, we have mainly two kinds. One is classification and one is regression. And for this project, we are mainly focused on the regression supervised learning algorithms. And why so? Because regression actually helps us to predict. Okay, regressional analysis is a set of statistical process for estimating the relationship between dependent variables and one or more independent variables. So here we have the equation for a simple linear regression, which is y is equals to a plus bx plus u. So the independent variables are basically the input factors, and the dependent variable is basically our output, which depends upon one or more input factors. So for our project, the input factors will be the sunlight, temperature, and the soil moisture, and the output is going to be the growth of the plant, which we are measuring in terms of the height difference. Okay. Now, which are the regressive models that I've implemented in this project? We have mainly used the decision tree regressor, the random forest regressor, the SVM regressor, and the MLP regressor. And a regression model provides a function that is going to describe the relationship between one or more independent variable and a response, which is a dependent on the target variable. Okay. And this relationship can be represented using a linear regression model. And just I said right now that in order to measure how accurately a model is working, we need certain metrics. And what are those metrics? We have mean absolute error, and then we have the mean absolute percentage error. You can find the formula right on screen. And we have the mean square error as well. And in these formula, the n stands for the total number of observations. That is the number of records we have in our data set. Yi represents the actual output, and yi cap is basically the predicted value, predicted output value. Okay, let's come to the code. So we have already imported the data set and we have displayed the data set. So this is my data set. Now what I want to do is I want to drop certain columns. Okay, so like I said that we need just the three input parameters, which are the independent variables which affect the growth of the plant, which is namely the sunlight, temperature, and moisture. So for that case, what I'm going to do is I'm designating X to be my input data set and Y is going to be my output data set. Okay. So in the input data set, I just want the three columns. So I'm just going to drop the other columns, which is day number, date, plant height, and height difference. Because anyways, day number, date is not going to affect in the prediction. it's not going to help me in predicting the growth of the plant. Okay, so what I'm going to now have are just the 3 columns in my input data set, and in the output data set I just want one column, which is the height difference. And what I'm going to do is I'm going to designate that both of these should be my numpy arrays. So now if I go and print the type of X and Y, it's going to tell me that both of these are numpy arrays. And why we are doing this? Because we want to make sure, or we want to ensure that we are actually working with similar kind of data set. Otherwise, the models are not going to perform properly. So now we are ensured that the input data set and the output data set both are numpy arrays. Okay. And now we need to do the train test split. Now we all know that when we have our machine learning models, what we do, we actually train that model on some part of the data. And once the model has been trained, we test how well that model is working on the remaining part of the data. So that is what exactly we are doing. We are doing a train test split, and I'm specifying that zero point 0.2 is going to be the test size, which essentially means that about 20% of the data is going to be reserved as the testing data. So on the remaining 80% of the data, I'm going to train the model, and on the 20% of the data, I'm going to test the model. So now if I just print the X train is basically the training part of the input data set, and Y train is the training part of my output data set. I can essentially see that this is my training part of the input data set, and this is my output data set. Okay. And if you see, it's basically 80% of the 30 records that we have. Okay. Now, as I've already discussed, that we will be talking about 4 regression models that we will be implementing. So let me just take you to this code. The first regressor model that we have implemented in our project is basically the decision tree regressor. Okay. So what we are doing is that we are implementing the decision tree regressor, and we are training the model on the basis of X train and Y train, which is essentially the training part of the input data set and the training part of the output data set. On these two, I'm actually training my model. And once the model has been properly trained, I want the model to actually predict the data on the basis of the test data set. Okay, on the basis of the test part of my input data set. And those predictions I'm actually storing in a test pred variable. And what we can do is now to get the accuracy, how accurately my model is working, we want the mean absolute error, mean absolute percentage error, and the mean squared error. So for that, we are passing the Y test, so which is basically the test part of my output data set, and the predictions which I'm getting. Okay, and I'm rounding them off to 2 places after the decimal. And now I'm printing. So let's see what we are getting the output. So you can see the mean absolute error for the decision tree regressor model is 0.07. Mean absolute percentage error is 0.1. Mean square error is 0.01. And the R2 score is negative 0.14. Now what is R2 score? It's basically a statistical measure that represents the goodness of a fit of the regression model. And its value, so if it is a perfect one, it means that the model is perfectly fitting the data and there is no difference between the predicted and actual value. But obviously we are not going to get such an accurate model which is going to exactly predict the value as it is as equal to the actual value. So you can see that now on the basis of the test data set, we have actually got the actual value, which is the actual height difference of the plant and the predicted height difference. Okay. And now if you just see here, we are actually getting 1, 2, 3, 4, 5, 6. We are getting 6 values. And why so? Because 20% of 30 is going to give us 6. Okay. So now we have designated on the 6 records, we will be performing the test. We are testing the model on the 6 records. And therefore, for each of those 6 records, we are getting the actual value and the predicted value. Okay. And now let's see if we want to plot the data, like we want to plot the actual height difference as versus the predicted height difference, just to get a proper understanding how this model is performing. We can plot that with the help of our matplotlib. Okay. And now you can see that for the 5th record, both of these coincide, which tells me that the actual value and the predicted value are same. If I just come here, you can see, yes, the actual and the predicted value of the height difference are actually same. So in this way, we can get a better understanding how our model is performing with the help of a better visualization like these. So this was our decision tree regressor. Now, next we come to our next regressor, which is the random forest regressor that I've implemented. And it's basically on the basis of ensemble learning. Like if I just come back to the presentation, this was our decision tree regressor. And we all know that it's basically a decision making tool that uses a flow chart like a tree structure, and it is a model of decisions, and all of those possible results including the outcome, input, cost and utility are given in the form of nodes. So if we just see here what how a decision tree regressor model works. First, a decision is made. If it is true, we choose this path, and again we have to make a decision. If it is true, this is the outcome. If it is false, this is the outcome, and so on and so forth for each and every decision. So this is how a decision tree regressor works. And I've already shown you the code. Let's come to the next model that we have discussed. This is a random forest regressor. And it's basically an ensemble technique which is capable of performing both regression and classification with the help of multiple decision trees and a technique called bootstrap and aggregation, which is commonly known as bagging. So what happens in random forest models, basically we are having multiple decision tree models which are acting as the base learning models. We randomly perform the row sampling and a feature sampling from the data set. We give to these base learning models, and this part is called bootstrap. Like here, we have the data set, which is the size of the data set is m cross n, which means m rows and n columns are present in the data set. Now, what we do is we randomly actually divide this and we form, let's say, n number of decision trees. Each one is given m dash n dash size of the data set, and this part is called bootstrapping. And the output that we get from each of these individual decision trees, all of these are aggregated to give us the final output, and this part is called aggregation. So this is basically an amalgamation of bootstrapping and aggregation. So let's come to the code now. So here we have implemented the random forest regressor. So again, this is pretty much similar like the previous one. We are first training the model on the basis of X train and Y train, which is the training part of my input data set and the output. And once the model has been properly trained, I want to test that model on the basis of X test, which is the test part of my input data set. Okay. And after that, I am again calculating the mean average, mean absolute error, mean absolute percentage error, mean squared error, and the R2 score for this model. And then we are printing those results for each and every test data. So you can see the MAE for this particular model is 0.1. Let's go to the previous model. So for that, it was 0.07. So we can definitely see that the mean absolute error for the decision tree regressor was lower than that for this random forest regressor model. So lower error means better accuracy. It means that it's working better. That model is working better for our particular data set, right? So in this way, we can see the MAE, the mean absolute percentage error, mean squared error, so on and so forth. And we can also see that what the actual height difference was and what is the predicted value. In this way, we can get the actual versus the predicted value. Again, we have plotted the result, and this is how it is for the actual versus the predicted value for the random forest. Next, we have our SVM regressor, which is basically the support vector machine, which is used for regression algorithms. So if I just again come back to my slide, SVM regressor, it's a popular machine learning tool used for classification and regression. And SVR, it uses the same principle as support vector machines. In other words, it is the approach of using SVM to solve the regression problems. Now, this is our implementation of the SVM regressor. Let's come to the code. So here we have implemented SVM regressor. So this is basically the code where we are again, training the model on the basis of X train, Y train, and then we are also going to get a gamma value for this particular model. And after this, what we are doing the same thing, we are just testing the model on the basis of X test so that we can get the values for these metrics, which are going to give us a reflection of how accurate or how precisely the model is actually predicting the value. And lastly, we have also predicted the values of the actual value versus the predicted value. And lastly, we have our MLP regressor. So this is the fourth regression algorithm model which I have used for this project. So MLP regressor is nothing but a multi-layer neural network, also called a multi-layer perceptron. I hope you know what is a neural network. It is a type of network which mimics the human brain thinking capability. The human brain central nervous system, that computation or that thinking capability is reflected or mimicked in a perceptron or a neural network. It has three layers, including one hidden layer. So the middle one is the hidden layer. And if it has more than one hidden layer, it's called a deep artificial neural network. And an MLP is a typical example of a feed forward artificial neural network. So whatever intermediate output we are getting of one layer, it is basically fed forward to the next layer. It's not doing a feedback. It's actually fed forward to the next layer, to the intermediate next layer. And then we go to the implementation of the MLP regressor. The same thing we have done, and then we have got the mean absolute error, percentage error, mean square error, and the R2 score. And again, we have got the actual and the predicted values. This is the actual height difference, which we have noted. And this is the predicted value, the value that is predicted by this model. And then we have plotted the values for the actual one and the predicted one for this MLP regressor. Now, why I've used these four regression algorithms? Because I wanted to compare the performance of these four regression models, like which model is predicting the most accurately or most precisely. For that, we have used these four models. And once this was done, let's come to the observation and result. So what I've done is, on the basis of the metric values that we have seen, I have tried to compare the performance of the regression algorithms. So here I have plotted on the basis of mean absolute error. So we can see that the random forest model is going to give us the maximum mean absolute error. And the maximum error, it means that it's going to perform the worst for this particular data set. And we can see the decision tree regressor model is having the least mean absolute error, which means that it's going to perform the best for this data set. So if we are implementing this particular model, the difference between the predicted and the actual height difference value is going to be pretty minimal. So it's going to give us the most accurate result. Then I have also plotted the performance of regressor algorithms on the basis of mean absolute percentage error. And lastly, for mean square error, we can see that all of these four algorithms are basically performing at par. Now let's quickly talk about the future scope. So till now we have understood that we can, with the help of these regression algorithms, we can predict the growth of the plant on the basis of these three factors, namely sunlight, temperature, and moisture. So any day, if I am seeing that the growth of the plant is not as expected, we can now predict that what can be the underlying cause. It can be that maybe on that particular day the plant did not get optimum sunlight, or maybe the plant is not getting optimum soil moisture that it requires to absorb the nutrients from the soil. So all of these deductions can now be made once we have done this kind of research that I've just showed right now. But the plant growth is not just restricted to these three factors. We have some other factors as well. And one very important factor is basically the soil nutrition. And when we talk about soil nutrients, there are three main nutrients which directly affect the plant growth, which is namely nitrogen, phosphorus, and potassium. So in the market, there are plenty of NPK sensors that actually help us to record the NPK values. And with that, we can actually do a similar kind of analysis where we will be able to analyze that whether the plant is getting the optimum level of this NPK elements or not. We also have one more very important factor, which is the pH of the soil. And we have certain pH sensors as well, which help us to sense the pH value of the soil. And in that way, we can again do a similar kind of analysis to analyze that whether the soil is getting all of those, whether the plant is getting all of those optimum factors which are required for the proper growth of the plant. Now, a very interesting scope or expansion, possible expansion of this project can be that the marigold plants are very commonly affected by a pest infection, which is called a spider mite infection. And often what happens that a spider-like cobweb engulfs the entire plant, and because of that the sunlight is no longer able to penetrate the plant and reach the leaves of the plant, and within a matter of days actually the plant dies. And this infection is so contagious that it actually infects all the adjacent plants. Like if we have a garden full of marigold plants, and if one plant gets affected, within a matter of 2 to 3 days the entire garden, all the plants will actually get affected, and after a week or so the plants are going to die. So in this way also we can incur a huge loss if such kind of pest attacks affect our plants. So what we can do is, if a process is implemented in which we can detect the infestation of such a pest on our plant as soon as it starts, then what we can do is, either we can do two things: either we can set up an alert sending system where the farmer gets alerted that a pest infestation has started on the crop or on the plant, and then that farmer can actually spray the necessary pesticides and insecticides on those plants well in time, so that we are not incurring any loss due to the death of these plants. Or what we can do is, we can also actually set up an automation where this process is automated. That is, whenever the spider mite infestation is detected by a camera sensor, what we can do is, we can do this process automatically. Like we can we can create an automation process which can directly or automatically spray the pesticide or the insecticide on the plant, and that is going to curb this pest infestation. So all of these are the possible future scopes on which this project can be expanded. So what is the conclusion of this project? Basically, we have seen the importance of these three factors on the plant growth, and we have also seen how we can very nicely we can perform the perfect amalgamation of Internet of Things and machine learning regression algorithms to actually devise a solution which is very useful in today's agricultural sector. And smart agricultural solutions have already started creating quite a buzz in recent times, and they also promise to bridge the gap between the demand and supply chains in the agricultural sector, and also improve the efficiency of agriculture and decrease the underlying latencies. So this was actually all about from the project point of view. Very quickly, I would actually like to talk about some concepts of big data which are prevalent in today's industry level. And why? Because such kind of censored data can also be classified. Like when we are getting huge amount of data from the sensors on a daily basis, that can also be classified as big data. So it's very important to understand the use of big data in today's scenarios. So let me just take you quickly. So introduction to certain big data concepts that are finding their applications in industry level. So if you just think about for a moment that what happens when you go online every 60 seconds, this is the scenario. Okay, so like you can see these number of Snapchat stories are posted. These are the number of tweets that get tweeted in just a matter of 60 seconds. So this is the current scenario that is going online. So we can understand why handling, processing, proper maintenance of the data is so important. And big data is actually finding its application in each and every sector, whether it's a marketing sector, whether it's computer sector, analytics, technology, healthcare, research, everywhere we are dealing with huge amount of data. And if you want to talk about what is big data, we all know that big data is mainly classified using these 5 V's: volume, which is essentially talking about huge amount of data velocity, a data that is incoming at a very high rate. Variety, it's like a huge variety of data. We have structured data where the data is essentially in the form of tables. We have unstructured data, like the real time streaming data, audio, images, etc. We have semi structured data as well. Then value, this data is of huge importance. And veracity, that is, we need to be able to authenticate the data, like this data needs to be accurate and precise. So all of these are the characteristics that help us to characterize a data as big data. Now let me tell, like, who are the people who are involved in this domain. So we have data scientists who mainly are working using skills like mathematics, programming, communication, and the tech stack that they mainly use can be SQL, Python, R. Then a data engineer who is mainly an IT worker whose primary job is to prepare the data for analytical and operational use cases. Typically they are responsible for building data pipelines. Then ETL, which is extract, transform, and load processes. The skills required for a data engineer are programming, mathematics, big data. Then we have tech stack used by a data engineer is mainly Hadoop, NoSQL, Python. The list does not end here. It's a very short and concise list. Then we have a data analyst whose job is mainly to gather and interpret the data in order to solve a specific problem. The skills required for a data analyst is statistics, communication, business knowledge. The tech stack used can be Excel, Tableau, and SQL. Now let me talk about the ETL process briefly. So what is ETL? It's basically the heart of any data engineering workflow. ETL stands for extract, transform, and load. So extract is basically when we gather the data or extract the data from various sources. It can be databases, which can be our normal SQL databases or NoSQL databases as well. NoSQL stands for not only SQL. So it's basically beyond the traditional SQL databases. We can have files, we can have SaaS applications, we can have application events, API from APIs, etc. So first we extract the data from various data sources and we place that data into the staging area. And now we transform the data, apply various transformations. We clean the data, we apply the business logics to the extracted data. And once that has been done, we load the data into the data warehouse, and after that we can actually create dashboards, reports. We can analyze the data using various visualization tools. Now, top big data applications. You can see big data finds its application in education sector, e-commerce, airline, fast food joints, agriculture sector, banking, weather patterns, government, healthcare, etc. And this is basically the architecture for Snowflake. Now, very briefly, if I have to say, Snowflake is basically a technology that is based on data warehousing. So it's again based on the ETL concepts. And we can see the difference between Lakehouse and Snowflake. So these are certain industry terms that you will get to learn and use once you come to the industry. So in Lakehouse, what happens is Lakehouse is basically the perfect combination of a data warehouse and a data lake. So data warehouse actually stores mainly historical data, huge amount of data, and a data lake mainly stores various kinds of data. Like in warehouse, there is a limitation that you can just store structured data. But in data lake, you can store structured, semi-structured, as well as unstructured data. But data lake also has certain limitations, like security is a major concern in data lake. Also, the data in lakehouse is not always ACID compliant. In that case, we can have redundant data stored in data lake. And from there, we have got the perfect solution, which is a lake house, which is created using the best of these two worlds, which is warehouse and data lake. We have got the lake house in which you can store structured, unstructured, semi-structured data as well. The data is going to be ACID compliant as well, and there is not going to be any data redundancy. We also have a unified governance that you can implement on the lakehouse. So this is basically the architecture of a normal data warehouse, where we do the ETL process from the various data sources. We transform the data and then we load that data, after which we can perform the reporting, analytics, data mining, etc. And this is my data lake, where, as I've already told, we can store various forms of data. Like you can store flat files, you can store the data from IoT sensors, the audio and video files, the social media data, etc. All of this can be stored on the data lake. And then we have the lake house, which can store each and every form of data. But on top of that, we are having a unified governance layer. So now the data is governed from a unified platform, and there is no data redundancy. The data is asset compliant. Security is also very high in Lakehouse. So this is basically the data lakehouse architecture. And okay, now I would just like to briefly talk about the Spark architecture. What is Spark? When you will be dealing with big data, you will come across something called Spark. So in Spark, what happens? We are actually implementing two concepts, which is parallelism and distributed computing. So when we are dealing with big data, we are essentially dealing with a huge volume of data. And to process and transform that huge volume of data by just one computer is not very efficient. It's going to take a huge amount of time, and not only time, the storage, the computation, all of this can actually lag. So in that case, what we do is, in Spark architecture, what is done is we have a driver, and then we have worker nodes. So the driver is actually going to divide the work into the worker nodes. In that way, we can, and the worker nodes are parallelly going to do the computation on their own. So in this way, we can implement the distributed computing concept as well as parallelism uh, in the Spark architecture. So this was basically the end of a very brief introduction to big data and how it finds its application in industry. So I would just like to ask Prashanjit Dey sir once that if I have time, then I would like to do a brief overview of PySpark. Otherwise, we can
Uh,
go for Q&A.
yes, we have time. If you can briefly discuss about it, you are welcome.
Okay, sure. Thank you, sir, for the confirmation. So let's come to PySpark. So just let me give you a very brief overview first that what is PySpark. So Databricks is basically a tool that we use to implement various big data workflows. Okay. And in that, Spark is going to provide us, like if I just search about Apache Spark, you can get that it's an open source unified analytics engine, which is utilized for large scale data processing. And in the Spark environment, when we are coding in Python, it's essentially PySpark. Okay, so you can just simply say that when we are implementing Python in the Spark environment, it is basically PySpark. And Databricks is a tool that we use in industry to implement the big data workloads. It's an all-in-one tool that is built on the lakehouse concept that we have just now discussed. And you can implement your normal SQL workloads, machine learning models, everything, data science, everything can be done from this Databricks platform. So we will be having a brief walkthrough on PySpark, but before that, let me just show you this is how the workspace of Databricks looks like. So what we do is, it's basically we write the code in notebooks. Okay, and the languages that are supported are Python, R, Scala, and SQL. So you can write your code in these four languages in Databricks. And for executing any code in Databricks, what we need to do is we need to create a cluster. So what is a cluster? It's basically a set of virtual machines, and it is basically a compute resource. It helps us to implement the Spark architecture. That is, whenever we are actually creating a cluster, by default, we can also do it manually, like a driver and a specific number of worker nodes or executor nodes are created, and then it implements the distributed computing and parallelism concepts. So what I'm going to do is, firstly, I need to create a cluster. So for that, what I can do is go to create cluster, and here we need to give the compute name. So I can just give any name for now. So let me just give it seminar practice, a random name. And since it's the community version, we are not going to have all the features enabled in Databricks right now. If you are using from your work profile, then you can get much more flexibility in choosing the options. But since this is a community version, we are not going to get much here. But you can see that a driver is designated, which is going to have this memory, and we cannot actually manually designate the number of workers we want, how many cores we want, and that can be done actually in the paid version. This is the community version, so these are not enabled here. And I'm just going to click on create compute. And what it's going to do is it's actually going to create a group of virtual machines on which I will be able to run my Databricks jobs or Databricks workflow. So till the time it is going to start, we can come back to our notebook. Okay. So I will just once this is up and running, we will attach our notebook to the cluster. Okay, so it's going to start and then we can start executing our code. So let me give you a brief walkthrough what this code is all about. So what happens is mainly in Spark, we talk about data sets, we talk about data frames. Now, data frame is basically the parallel or it's a reflection of tables that we have in our normal day-to-day life. Just similar to that, we have data frames. Okay, and this is how we can create a data frame. Now, before data frame, we had something called an RDD or a resilient distributed data set. And now we have data frames. So this is the way in which we can create a data frame. You can see this is the data that we are passing. So the data that we are passing within the round brackets, or each tuple represents a row of data. And this, so we can say that we have 1, 2, 3, 4, and 5 lines of data. So you can see now the cluster is up and running. So the data, so this is the data, and then what we can do is we can actually mention the columns which we are going to have in our data frame. So I want a first name column, middle name, last name, a DOB, which is date of birth, gender column, salary. And what is the normal syntax for creating a data frame from this data and schema is that df is equals to spark dot create data frame. This is our general syntax. Then we pass the data, and in schema we pass the columns. Now, I hope you all know what is a schema. Schema is basically the logical definition of a data frame or a data set. So now if I just run this, to run a particular cell, we can either click on this button or we can just press the control enter keys on our keyboard. So it's going to run the command. And now you can see that the data frame has been created. Okay, so this data and the columns together, they have been now incorporated into this data frame. Now, if I want to see the data frame, I can simply do a df.display. Display is a command. It's basically an action. So whenever we do the display command, it triggers an action. It's going to display the data set. So if I just do a control enter, you can see again, I'm going to get my data set. So this is how my data set looks like. You can see this is just like a table. We have our rows. We have 5 row data, 5 rows of data, and we have these columns. And okay, so let me tell you, okay, in Databricks or in Spark, we have something called transformations and we have something called action. So transformation is when we transform the data. So in case of transformation, we are actually overwriting or we are creating a new data frame. For example, if I want to do a group by, that is, I want to group the data on the basis of certain criteria. I will do a group by. So in that case, it is a transformation. But when we want to perform a certain action, we are not changing or we are not transforming the data. We just want to perform certain action on the data. It is called an action. So we have two things, transformation and action. And when we conduct actions on the data, they actually create something called a DAG or a directed acyclic graph. Okay, and that gives us a proper visualization of how the computation is actually happening. Like for now, you can see these are the jobs created. If I just go to view, here I can see something like this. This is called a DAG. It's the DAG visualization. It is, as you can see, it shows a graph of the stages executed for the job, each of which can contain multiple RDD operations, like we can do map, filter, etc. So let me tell you, like Spark is basically a very, a compact reflection of the map and reduce concept that we have studied. So that's why we are talking about this map and filter. So here you can see that some parallelism is done, then map partitioning is done. So this is basically how the job is functioning, how the data flow is happening. So it gives us a visualization of how the computation is actually taking place. So you can always go to these DAG visualizations. So let's say I want to get the count of the data. What I can do is I can simply run this command, which is df.count. So I want the count on the basis of the salary. By default, it's going to pick the salary column. And here we can see that there are three people whose salary is 4,000. There is one person whose salary is 3,000, and there is one person whose salary is -1. This is an arbitrary number, but I can just do something like this and it's going to give me that output. Okay. Okay, so you can see that there are 5 people and it's throwing some error. Okay. Anyways, so this is how we can like get the count of the data, which gives me the number of like rows of data I have in my data frame. Okay. Now next, as I've already told that we can write the code in these 4 languages in Databricks, which is Python, SQL, Scala, and R. So anytime I want to switch between different coding languages, what I can do is I can either change it from here, or what we can do is this person SQL is nothing but a magic command. So even if it is by default set to Python and I want to write some code in SQL, I can just simply do a %SQL. And now you can see that this has changed to SQL automatically. And now I can write SQL command. Okay. Now we can perform the normal SQL workflows in Databricks as well. Like here we are creating a table. So the syntax is quite same as in normal SQL. So create table. If not exist, it's going to create a table by this name. And here we are passing the schema of the table, which is that we specified that the table is going to have 2 columns. One is the ID column of the type int and name column of the type varchar, which is going to have, this is the length, 20 characters. Now let's say I want to alter the table and I want to add a column. I can do something like this, that alter table. This is the table name and I want to add a column, and this is and I want to add a column of the name age, and this is the data type of that particular column. So I can just run this. So it's going to create the table. Because you can see that the practice table has already been created, and this is in the DBFS. So DBFS is basically the Databricks file storage. So this is the by default location where all the tables or the data that you the tables that you create or the data that you upload, by default it's going to be mounted into the DBFS. But later you will understand that DBFS is like Databricks does not recommend storing any sensitive data or uploading any sensitive file onto the DBFS, because it's not very secure, because everyone can actually easily access the DBFS, and that's why it's not recommended to actually use the DBFS storage. So then what we can do is, okay, so here what we can do is, for example, we have a data frame and we want to perform some SQL operations on that data frame. So what we can do is we can actually create a temp view out of that data frame, and for that, this is the syntax: create a replace temp view, and this is the name of the temp view. And once this is done, it actually creates something like a temporary table, and on that temporary table now we can run our SQL command. So anytime I want to write SQL in the Spark architecture, either I can write using the magic command, which is %SQL, or what I can do is I can write in Spark SQL as well. It's similar to normal SQL. We just need to mention spark.sql, and within quotes we need to write our SQL command. So the SQL command is now being passed as a string, and this will be actually this transformation or this action will be performed on the data frame, and now we will be storing it into a new data frame. And if we want to if we want to print the schema or the data types of the particular columns, we can do a print schema. So what happens is we are getting that the first name column is of the type string, middle name is of the type string, salary is of the type long. So in this way we can actually print the schema of our data frame, and we can also display the data frame using either dot display or dot show command. Next, what we can simply do is, for example, if we have multiple columns, like now for demo purposes, we are just dealing with a very small data frame. But in production, what we do is we have huge data sets where we have maybe hundreds of 50 plus columns or hundreds of columns. But we just want to like work on or perform certain transformation on some specific columns. In that case, we can do this, that we can select those columns and we can then perform the transformation. So for example, here we have just selected the first name and last name column. We can get the data types of the columns using dataframe.dtypes command. Next, what we can do is like a Spark session. We have something called a Spark session, which is basically the starting point of a Spark program. So this is something which is not essential right now. What we can do is, okay, so we have seen how we can create a data frame by manually ingesting the data. What we can also do is we can also create a data frame from an already existing CSV file. So what we can do is, first we can upload the CSV file to our DBFS. So for that we will go to catalog DBFS. In file store, what we can do is we can just do upload, and then we can click on here, and then we can select the file that we want to upload. I already have it uploaded, and then we can copy the file path. And how it is done is, for example, I want to load this data. We can just click on this arrow here, and we have this option copy path. And here we have two formats in which we can copy the file path. I will select the Spark API format. We can just click on copy and we can close. And this is the syntax for actually importing or loading a CSV file and then storing that result into a data frame. That is spark.read.format is CSV option. We need to specify that whether our CSV file is actually having a header or not. And we know that our CSV file is having a header. So for that case, we are mentioning header is true, and dot load, in that we need to mention the file path that we have just copied. Now let's say once this has been done, a data frame has been created, and I want to just display what we have in our CSV file. I can just do the data frame dot show. So this is my CSV file data, which is displayed right here. And if I just do type of this data frame, if I want to check it, it tells me that this is basically a data frame, right? And then we can print the schema. Again, it's going to give me the data type of each and every column. Now, if you carefully notice, you will see one thing, that the experience, which is basically the number of years a particular person has experience in teaching that subject, which is a number basically. Here it is taking this as string. Why so? Because in Databricks, we have something called infer schema feature, where Databricks can automatically infer the schema or the data type of a particular column. Like we don't have to manually specify what the data type of a particular column should be. It can, by default, it can infer the schema. But obviously, it is not always 100% accurate. As you can see in this case, the experience it has taken as string, since we haven't manually mentioned that the data type of this column should be integer. Okay. Now again, we can select the columns, particular columns. What else we can do is, for example, we want to add one more column where we want to see what is going to be the number of years of experience for each of this person after a time period of 5 years. So this is the syntax, the data frame dot with column. So here we are adding the new column, whose name is going to be experience after 5 years. And we are selecting the experience column present in my data frame, and I'm just adding 5 to it. And then if I just do dot display or dot show, you can see now my data frame is having one more column, which is experience after 5 years, and it has actually added 5 to this experience column. Next, again, we can do what we have here. We have again read a CSV file, and we have just displayed the data frame. Okay, what else? If we want to drop a particular column from our data frame, we can simply do data frame dot drop, and here we can specify the column which we want to drop, and here you can see we can no longer see the name column. What else? We can also do some filter functions on the data frame. For example, I just want to filter those records in which the course fee value is less than 2000. So I can use the filter function, data frame dot filter, and here I need to mention what I want the criteria to be. So I want the course fee to be less than 2000, and you can see I'm getting only those records for which the course fee is less than 2000. I can also use multiple filter functions. Like here we have filtered those records in which the course fee is less than 2000, and I want those records where the experience of the person is also greater than 1 year. So in this way we have got these 3 rows of data. Then we can perform some group by operations, which is basically a transformation. So and we can perform some aggregate functions as well. Okay, like here, what I've done is I want the salary for each person on the basis of the name of that person. Like if you just look at the data set, here we can see that Krish teaches in data science as well. Krish also teaches in big data, and Krish also teaches in IoT. So what I want is, what is the salary, the total salary that Krish gets, from these 3 departments that he teaches in. Similarly, for Amrita, who teaches in 3 departments as well. So in that case, I want to do a group by name. And what I want is, I want the sum of the salary. So here you can see I'm getting that Keshav is going to get this much amount of salary from, this is the total salary that he is getting from the 3 departments. So in this way, we can apply group by transformations. Let's say I want the sum of the salary that is, on the basis of each department. Like what is the sum of the salary of the professors who are teaching in IoT, who are teaching in big data, and who are teaching in data science domain. So here we can group by the data on the basis of the department column. In this way, instead of finding the sum of the salary, we can also find the average salary. So we can just use the mean function along with the group by. So here we are actually aggregating various transformation functions. We can also get the count of the professors, like professors who are teaching in IoT, professors who are teaching in big data. So we get, there are 4 professors teaching in IoT, 3 in big data, 2 in data science. So we can use the count function. In this way, we can also get the total salary. So this is also an aggregate function in which we can actually get the total salary of all the professors. Okay. Then we can group by on the basis of name, where we want the maximum, like I want a maximum salary that that person gets, right, out of the 3 departments. Okay. Now, like I was telling that we have data frames, we also have RDDs, and this is the process in which we can create an RDD, which is a resilient distributed data set. So likewise in data frame here also we need to pass the data. We can pass the data manually. In each tuple, it actually represents one row data. And then in the entire list, we have the data that we want to pass into the data frame. And we need to create a data RDD using the parallelize function. Okay. So now if we do rdd.collect, it's actually going to display the values that we have in our RDDs. We can also create an RDD using a text file. In that case, this is the syntax, and here we need to pass the location of the text file. It's going to create an RDD from that external data source. We can also create something called an empty RDD, which means that we are not passing any data as of now in our RDD. Then what we can do is, like I said, that in Databricks, it actually has a feature called infer schema, by which it automatically detects the schema, but it is not always accurate. What if we want to manually specify the schema? And this is how we do it. Okay, we need to import struct type and struct field, and then we need to import what are the various data types that we want to specify. Here we are just mentioning that we have three columns, which is first name, middle name, and last name, and all of these three are of string type. So the values that are going to be present in these three columns are going to be string type. And yes, these columns are going to be present. That's why we are putting true value here. So we can convert empty RDT to a data frame. So this is how you can convert an empty RDT to data frame. Here we have the toDF function, and in that you need to pass the schema. And what is the schema? Schema we can specify here, like we have manually specified that schema, that it is going to have three columns, and these are the data types. In this way, we can create a data frame from an RDD as well. Next, what we have here is, this is the data. Okay, and here we are creating the data frame. So in this data set, what we are having two columns. One is the serial number, and then we have certain codes. So if we just normally show the data, you can see that some of the part of the data is truncated. So in case I don't want that to be done, I can just set the truncate property to false. In this way, we can get the entire data displayed. Let's say I just want two records to be displayed, so I can just select that I want two records to be displayed only. Then if I just want data to be truncated after 25 characters, I can set the truncate property value to 25. Then I want the data to be displayed in a vertical fashion. I can select vertical to be true. And all of this that we have seen till here, all of this can be incorporated in one command. Like we are manually giving the data, we are manually specifying the schema, and then we are actually creating a data frame. So this is the data frame that we are getting. Then we can also add and change the structure of the data frame. Like we can add one more column. Here we are adding one more column, other info, and in that what I'm doing, I want the data from the ID column, I want the data from the gender column and the salary column. And also what I want is, I want in the other info one more data where I'm applying this condition, that is when the salary column value, and I'm casting that to integer type. Why? So in case we are not manually defining the schema, then Databricks is going to consider that particular column value as string. So in that case, we are manually or explicitly casting the value of that column to integer, and we are checking that if that value is less than 2000, we want to classify that salary as low. If it is less than 4000, it's medium, and otherwise it's high, and that we will be aliasing as salary grade. And all of this is present inside the other info column. And we are now dropping all the other columns, ID, gender, salary. We are dropping those columns. And now let's display this updated data frame. You can see now we just have the name column and we have the other info column. And in other info, we are having the values from the ID, the gender, the salary, and also the salary grade, whether it's high, low, or medium. Also, the data type, we can also mention the data type of columns to be array type as well as map type. Okay, so a column can also have array type of data as well as map type of data. So map type is basically like a dictionary type of data where we have key value pair. So in that case, for example, I want the name field or the name column to have array type of data. So what I'm mentioning in the square brackets, I'm mentioning that it's going to be composed of these three fields: the first name, middle name, and last name. And all of these are of string. And hobbies, I'm mentioning this to be an array type. It's going to have string type value. So all the values in the hobby field is going to be of the type string. And properties, I'm mentioning that it should be a map type column. So it's going to have key and value pair. And I'm mentioning the key is of string type and the value is also of string type. So in this way, we need to mention the data type for the key and value. Also, what we can do is we can actually print the schema in a JSON format. So JSON is also, it actually prints in a key value format, key value pair format. Here you can see that we get the schema in a JSON format printed. So all of this has been incorporated in this particular code where we have created the data frame. We have passed this data into the data frame. We have manually specified the schema of our data frame. And we have also added one more column, which is the other info. We have also added some columns which are of map type and array type. So all of these are the different transformations that we have applied on the data frame. And this was all about the very brief walkthrough I wanted to give you on Databricks. Why? Because this is how we actually are working with big data concepts in industry, because Databricks is a very important and a commonly used platform on which every person, like whether it's a data engineer, data scientist, a data analyst, every person can work on Databricks, because here you can not only work with SQL workloads, you can also implement your machine learning algorithms, you can work with big data all in one, and you can very efficiently govern the data. Security of the data is also intact and maintained all in one in a very unified platform named as Databricks. So this was all from my side. So thank you everyone for patiently listening. So if anybody has any question, you are free to ask.
Dear participants, any queries from your end?
What is parallelism?
Parallelism is basically like when we are distributing the work on the basis into certain nodes, like various nodes, and all of those nodes are actually performing their computation parallelly. So the work is going to happen a lot faster. So just one, instead of one computer doing the entire task, we are distributing the task, and all of those individual nodes are doing that computation in a parallel fashion. So the task, the load is also going to be distributed. We are not putting the entire workload on one machine or one computer, and the task is also going to be completed much faster because of parallelism.
Thank you.
Any other queries? Okay, so I hope there is no other query. Thank you, ma'am, for presenting a hands-on session. Okay, so I hope that the participants can understand that lot of things from these sessions. Okay, thank you for giving your valuable time and accept our invitations. Okay, thank you.
Thank you, sir.